And we are live. Takeo After Dark is back, people. Woo-hoo! Welcome back, my friends. Welcome back. And it's good to be back with you here at Takeo After Dark, the winter season. We've had, about 2 months off there, Dave?
2 months, yes. Not that we were sitting around doing nothing for 2 months, but it's been a
Hey,
a
speak for
busy 2
yourself.
months.
Speak for yourself. Yeah,
So
yeah,
was
we've been.
I'm starting up tonight, and I'm like, wow, we haven't done this. I had to actually go back to the calendar and take a. It felt like forever, but
Right.
in the world of this, 2 months is like nothing. Hey, man, we did this for 2 years already. We can keep going.
So, yep, and we're excited to be back for this 5-week winter session. And we're going to kick it off with a real big bang tonight. We're really looking forward to that. If you're new to us, there's a couple of new faces here joining us. Well, one not so new, one brand new for Takeo After Dark. Let's go with the not so new to start with. Tim Ward from Mechanical Hub. How you doing, Tim?
Mr. Barber, Mr. Holdorf, pleasure to see you again. Actually, John, we saw each other about a week and a half ago at HR, but good to see you digitally.
Yes, that's usually my best side, is my digital side. For the folks out there that don't know, Tim is with Mechanical Hub, and Mechanical Hub is like our co-sponsor, our cohort, our co-partner in crime here for Takeo After Dark. Tim, could you share a little bit about what Mechanical Hub is and what you guys do, and what our viewers here can get out of Mechanical Hub?
Sure, thanks, John. Mechanical Hub simply is a digital media platform for the HVAC and plumbing industry. You can go to our websites, be it plumbingperspective.com, hydronicshub.com, or our first platform, mechanicalhub.com, to find all kinds of news and industry knowledge, working with manufacturers like Takeo and others to give contractors the best information, become better and smarter at what they do. Obviously, our social media platforms and our newsletters are some of the tools we use to engage and work with contractors across the United States and really across the world, since we're digital. So we're happy to be part of this once again. 5 weeks, the winter solstice, to enjoy
right.
and hopefully connect lots of people with Takeo and mechanicalhub.com.
Well, awesome. And you guys do have some of the best online content out there. And even though Eric once again couldn't make it, Eric Ani does create some of the best stuff out there. So one of these days he's going to join us, and time as we know it will cease to exist. I think that's just the only way I can describe it. Now, the other handsome face that you folks are looking at is Alan Mercurio. Alan, welcome. Thank you for being with us. Tell us a little bit about yourself and that kind of cool place that both you and Dave are in right now.
Yeah, so I'd like to start before telling you just a little bit about myself. I do want to start by thanking you guys very much for all the support Takeo brings to both Oil Tech Talk and the Pennsylvania Petroleum Association. Dave's been here for the last couple of days. He's got another day to do his advanced hydronics, and we really appreciate all the training he brings to the table for us. And I thought, when he had mentioned that he was going to be doing one of your Takeo After Darks one Wednesday night, I thought, oh my gosh, would you like to do it from the lab? I would love for everybody to see if you look behind Dave, you can see so much of the equipment that your company made possible for our lab to be the lab that it is today. So maybe a little longer than I needed to go with that, but I felt I needed to get that out before I say anything else. As for myself, again, my name is Alan Mercurio. It's a pleasure and a privilege to be joining you guys for this. I'm the lead technical trainer here at the Pennsylvania Petroleum Association, owner and host of OilTechTalk.com and Oil Tech Talk the Business, which everything that I've done in training and consulting now funnels through the Pennsylvania Petroleum Association. And I've also now I'm the assistant director to our newly recognized school by the Pennsylvania State Board of Education. As of February 2021, the Pennsylvania Petroleum Association is now officially a school here in Pennsylvania with the mission of bringing people into our industry, putting them through a 10-week program, and hopefully filling some of those voids that we all of us here know we have in our industry. So.
Oh, that is awesome, and that's the work that the work that needs to be done. And thank you so much for doing that, Alan. That is awesome stuff.
You bet. Thanks, guys.
We've got to keep our pipelines filled with people. We need new blood.
That's right.
So terrific. And
So-
Dave, Dave, maybe a little bit during our mid class break, we want to take a little quick tour of,
Sure, definitely.
of Alan's facility. It's really incredible, and if you ever get a chance to go see it, where in Pennsylvania is it, Alan?
It's Middletown, Pennsylvania. It's actually Harrisburg. The address is a Middletown address. It's kind of weird in this area. Dave can tell even the hotels are listed like East Harrisburg, West Harrisburg. So, High Spire, Middletown, Swatra, the town of Swatra is all technically Harrisburg.
It's all
I
the
wanna-
same. Yeah.
We're on
go to Swatra.
yeah, we're on Eisenhower Boulevard, right off of the turnpike. Easily accessible, which is great for having the a location for the school. And anyhow, so I guess Harrisburg, Pennsylvania, to answer your question. But some people put that in their GPS and they can't find it because it's technically in Middletown.
All right. Well,
So
great. Hey,
it's a
go
neat
ahead.
facility here too, because they have a classroom upstairs and I've been doing some training up there the last 2 days. And I had this scheduled with Alan, I think back in August. And I just figured, all right, once we schedule Takeover After Dark, I'm like, oh, I'll just do it from the hotel room. And then I'm thinking, oh, wait a minute, I got all this stuff behind me here, and actually some of it's going to be on the topic that we're talking about tonight, which I see you just
ironically
started the
enough.
slides. I
There
know,
we
right?
go.
So
There we go.
and Alan is if we're playing Hollywood Squares, he's just up there. It depends on where I line up in the cameras right now, but Alan's there and he's pointing down at me. So excellent. So anyways, back to you, JB.
All righty. Well, excellent. Let's get this show on the road here, folks, and welcome again back to Takeover After Dark. And this is the winter season. And of course, there on the right, you see our patron saint, the one and only Bruce Campbell. Photoshop in the wrong hands is technically a weapon, and that's what I did. We put Bruce on Dorothy because our class tonight is closely spaced tees, low loss headers, and buffer tanks, otherwise known as lions and tigers and bears. Oh my. I promise we'll never do this to Bruce Campbell again. We had him hooked up to Bernie Sanders last year. Just this one night tonight, he's going to be on Dorothy, on Judy Garland. We'll figure out what we're going to do with Bruce next week. But that is tonight's class. If you are a first timer for Takeover After Dark, just a real quick outline of what we're all about. It's a 5-week winter online program. So starting tonight for the next 5 weeks, we'll be joining you on Wednesday night, and we're going to do a make good class on the following Tuesday night, a little bit later for folks out in the western half, but anybody can come. So you'll be getting information on that. In this program does require individual class registrations. We looked at doing it. You sign up once and you're in for all of the classes. The problem with GoToWebinar is they don't really do a very good job with that. You don't get reminders for the next class, and you can't get access to the recordings until everything's done, and you don't get a certificate until everything's done. So we just figured this ways makes it easier for you to get the other stuff. It's a little more work up front to sign up for 5 classes, but it makes it easier for you guys to get everything else. So about this time tomorrow night, you'll be getting an email, a follow-up email from GoToWebinar with a link to the recording of this program, as well as a link to download a certificate of attendance. So those will be coming your way tomorrow. We're going to have prizes for participation. We're going to show you how to participate in just a minute. We got some really funky t-shirts and cool things for you. So Dave is the master of gift giving disaster, and he'll be discussing some of those things later on. And we hopefully will have a few laughs. We're going to learn a lot and have a few laughs along the way. That's kind of our goal. That's our plan anyway. And so far so good, right? I think we find that when we laugh together, we learn together a little bit better. So none of us take ourselves too seriously here, which is a good thing. So we will have some fun as we go along. Control panel basics, just so you know how everything works. The audio section up front, clearly, I know some of you can hear me. If you can't, there's your audio section, and you can fine tune it there on your control panel. There's also a section for handouts. We have no handouts tonight, but we will have handouts in future sessions. So that's where you'll be able to do that. And then the most important part is the questions/chat function. Many of you have seen that already, but what I'd love you to do is to just go to that section on your control panel and give me a hi, hello, how are you? All right. just see what's going on. Okay, I just want to make sure you can hear me, make sure everybody's happy. Tell us we're handsome devils, anything you can think of to make it look good, so we know that you can hear us and you can all hear us and everything's good. So we have communication. This is the vital part of this, that we have two-way communication here. Excellent, excellent, excellent. And again, questions, folks, please ask them whenever they occur to you. We'll stay on at the end of this program as long as you want to answer whatever questions you may have on the topic of tonight and topics in general. We go all kinds of crazy places afterwards. But ask your questions as they come up. We'll take a break every few slides and try to address a few of them as we go along. So, it's not just us bleeding on inanely, on and on and on. All right, we want to break it up a little, because quite frankly, neither Dave nor I are all that interesting, so or dynamic. So we want to make sure that we break it up a little bit. All righty, and again, if you're on a phone or tablet, same thing, only different. There are your different settings there to do what you need to do. All righty. Also, just real quick, if you don't already, please give Takeo some love on social media. Dave and I will be starting up again next week our Monday Night Live on Instagram, where we will chat for about an hour. We started this last fall as a Monday Night Football pregame show. Well, football's over, so we'll find something else to do. So. But that'll be right around 7 o'clock on Monday evenings going forward. And this was a screenshot from our session with Eric Awney and Andy Mickelson from Mechanical Hub. That's me up in the upper right-hand corner, looking oddly like Abe Vigoda. I was looking at today. Doesn't it? Okay. Am I wrong? Yeah, it's fish. Okay, I look like fish. So maybe we'll do Barney Miller next week. Who knows? Okay. Also, Instagram, Takeo Comfort is the Takeo Instagram account to follow. Takeo Training is Dave, and J Barba Takeo Trainer is me. So give us a follow, and we'll be posting some content up there that you may find useful as well. And then join us again on Facebook. Make sure you follow our Facebook page. Also, we have a YouTube page with about 2,000 different videos for you. All of our past Takeo After Darks, Takeo Tuesdays, how-to videos, different profiles on products, things like that. You'll find that all there. And we also are obviously on LinkedIn. So please make sure you follow us there. All righty, our theme tonight, because, hey, we're back, right, is Welcome Back, Kotter. We have a theme every week. That's the other thing we have. We have a theme every week. And because we're back, hey, welcome back. Your dreams were your ticket out. Tonight's theme is Welcome Back, Kotter. And of course, I got to be Barbarino, because you just put a Reno at the end of my name and you got it, right? And Dave, of course, is going to be Juan Epstein. And and we're going to be talking about Epstein's mother, I'm sure, who writes all of his notes. I get notes from Dave's mother all the time excusing him from work, so why not here too? But you'll know our third partner in crime, Rick Mayo, has no character here because Rick's not here, man. Rick is in Canada doing some training on some booster pumps, on our new booster pump packages. So he is not with us this evening. He is in Canada and probably drinking a lot of Molson's right now. So because he's not here, Rick gets to be Horseshack. Okay. So are you ready, Dave?
I am ready, my man. I am ready to rock and roll.
Are you ready, Tim?
Always.
And Alan, are you ready?
Ready to learn.
Maybe he's not sure. I don't know. So let's get this show started. All righty. Tonight's topic, as we said, low loss headers. It's T's, low loss headers, and tanks. T's, low loss headers, and tanks. That's to do with modulating condensing boiler piping primarily. And we're going to discuss the 3 W's of T's, low loss headers, and tanks. And those 3 W's are, what are they? Okay, what are each one of these things? When should you use them? And why use one over the other? Because that's basically it. That's pretty much what we need to know. What are they? When should you use them? And why one instead of the other? When would you use one? When would you use the other? And why? All right, so we're going to discuss that tonight. For all 3 of these things, it's all about hydraulic separation. That's why they exist. That's why we use them. It's about hydraulic separation. What we want to do is we want to keep the flow separate. We want to keep this flow separate from that flow so they don't interfere. So this circulator and these circulators just leave each other alone. They don't impact each other. All right. So we keep everything separate. Why is this important? Well, in many cases, you're going to have one flow rate in your delivery loop down here, along this pipe, one specific flow rate for that, and a second different required flow rate for your boiler loop. And the boiler loop is usually a lower flow rate in residential hydronics. So we have to figure out a way to get these two different flow rates to work together without messing with each other, so we can not only deliver comfort efficiently, but maximize the economy of operation of the boiler itself, the thing that actually burns fuel. So that's why we do it. That's the point behind hydraulic separation. And each one of these things that we're going to talk about, T's, low loss headers, and buffer tanks, are different ways of doing just that. Okay. Now here, let me do a little erasure so you see what we have. First we had the closely spaced T's. Now we're showing you a low loss header, okay, in this type of an application. And and one thing we can say about a low loss header is it's pretty much a closely spaced T's built for you, more or less. It's a little more to it than that, but that's the bottom line. And then buffer tanks, of course, is just a really big low loss header. All right, really big low loss header. So we're going to get into the specifics of each of these, but I just wanted to get it on the table first. All three are about hydraulic separation or hydraulic isolation. Now let's talk about closely spaced T's. In your boiler piping arrangement that you see, you'll kind of get somewhat of a look of it here over on the right-hand side, where this is our boiler gazinta and gazouta down here, and we have our header down here, down at the bottom. There's some rules that need to be followed, and this is a manufactured kind of set of closely spaced T's for you, right? But there's some basics that we have to understand in terms of pipe spacing and in terms of length. So this is kind of the anatomy of closely spaced T's, the ABCs, if you will. A is right here. That's the common piping, the piping that's common to both the boiler loop and the distribution loop. All right. The spacing between these two T's is important. And right now we're going to just put that at 4 pipe diameters maximum. So we don't want to see more than 4 pipe diameters maximum, between these two T's. So right here, 4 pipe diameters maximum, that's A. We'll explain why in a second. And then B, all right, which is this way, but also this way, okay, on the inlet, we're looking at 8 pipe diameters minimum on the gazinta of these closely spaced T's. And then on the other side, we want a minimum of 4 pipe diameters before we go into a fitting or something on the gazouta side. So on the gazinta side, 8 pipe diameters. On the gazouta side, 4 pipe diameters. I'm sure you're all asking why. Well, let's discuss that. Lastly, before we discuss that, C, if we're going down, we're talking about like a thermal trap. We're looking at about 18 inches minimum, so we don't get any thermal siphoning in that respect. So in practice, okay, this is the theory, right? This is the theory. And Yogi Berra had a great quote about theory and practice. And he said, in theory, practice and theory are the same. In practice, they're not. I'm going to give you a second to write that down because that's some front of the room thinking right there, right? In theory and practice are the same, but in practice they're not. Meaning the real world is a little bit different than theory. But why you want to pay attention to these theories is here. So here we have just a header, okay? Just a header, and it's a 1-inch header, okay? So here I have my 18 inches here going out to say a towel bar, and here's another secondary going to a heat exchanger. So let's take a look at this. If my header is 1 inch, type in for me, please, what's the maximum A spacing? What are we looking at for each A? So if the header's 1 inch, what are we looking at for spacing between those two T's? Maximum, okay? Very good. Yep, 4 inches, exactly, 4 inches. Everybody's got it. That's what we're looking for. 4 inches maximum, not any more than that. 4 inches maximum. You can put them closer together than 4 inches. It's impossible to put them too close, right? But 4 inches is your max in that instance. And here's why, okay? The reason is, well, let's also take a look at this one before we jump into that. What's the minimum B spacing, okay, between here and here, all right? What's the minimum spacing between those two T's? See if you can type that in. Let's see what you got, all right? Let's see what you got. Some of you have it. Some of you have it. Yep. Some of you. This is going to be interesting. All right. Let's continue. Let's take a little bit of a look at this in some detail. Okay. First off, why 4 pipe diameters? Well, it's right here. To virtually eliminate pressure drop. Pretend you're water for a minute, and you're chugging along this here pipe, and you come to this intersection, and in front of you, you've got nice wide open highway, okay? It's clean, it's clear, there's no traffic, there's flowers on the side of the road, you got a nice view, it's a gorgeous drive, okay? But you could, if you take a look at this little right-hand turn here, you look down there, it's narrow, it's dark, there's broken glass, it doesn't look like it's a fun ride at all. Where would you go? Dave, where would you go?
Oh, I'm going where the flowers are, man.
Yeah, you're taking the nice easy road because it would be silly to go this way, especially when you look just 4 inches down the road and you're coming back down there. So it seems like a needless and dangerous detour, right? The closer those T's are, the easier it is for that flow to go straight. The only way any flow is ever going to go this way is by force, which is why we need a circulator, okay? So that's why we have a 4 pipe diameter max right there. Now, this other line here, which is kind of interesting, what goes into a T has to come out of a T. Now, this is kind of a fundamental of primary, secondary piping. So let's say coming into this first T, I have a flow rate of 7 gallons per minute, all right? When the pump is off, that 7 gallons a minute just shoots right through those 2 sets of T's and back out the other side. But let's say this circulator comes on, and this circulator is capable of delivering 3 gallons per minute. So I have 7 coming in, I'm yanking out 3. What do I have left in here? Well, simple math tells us 7 minus 3 is 4 GPM. So my flow rate going from right to left here in those T's is 4 gallons per minute. Now, this is the return, okay? This one's the supply, this is the return. So I still have 4 gallons per minute, or 3 gallons per minute, excuse me. I've got 3 gallons per minute in this leg. Let's say that's the boiler leg. So it's 3 gallons per minute and it's coming back hotter. So right here, I've got 4 entering this T, 3 entering the branch, coming out on the run, I'm back to 7 gallons per minute, okay? So what goes into a T has to come out of a T. Now what's gonna happen, if this is pumping into my boiler, this water's coming back hotter. So I'm mixing 4 gallons a minute of cool return water with 3 gallons per minute of hot boiler water, and that's gonna make 7 gallons per minute of something, okay? And we'll be going over how to figure out all that stuff in subsequent classes, but that's kind of where we're at right here. All righty, let me know if that makes sense. How is everybody out there? Everybody good? Pace is good? Any questions coming in there? Nope, there we go. All right, excellent, excellent. Now, we had a lot of different answers for the second part of this quiz. It's 12 inches, all right? We want 12 inches here because remember, going out, we had 8 pipe diameters, but going into a T, we wanted 4 pipe diameters. So in this case, it's 8 plus 4 equals 12. And that has to do with turning chaotic flow into smooth flow because we're mixing, let's say 4 gallons a minute of water here with 3 gallons a minute of water here. I'm mixing right here. What do you think that water is going to be once it mixes? You know, you hit that mix point coming out of the T, you're going to have pretty chaotic flow. and it's going to take about 12 inches for that chaotic flow to turn into smooth flow, so it'll work with the next setup. So in this kind of an example, you're going to want 12 inches if you have a single pipe system like that.
So I want to give you guys an example. I went to this job site many years ago that had this exact scenario, but they didn't have the 12 inches between. And these were injection pumps at the time. So that circulator that you see in the picture was very important in order to get the proper water temperature going out to the radiant floors. And the injection pump on the left was doing the left side of the house, and the injection pump on the right was doing the right side of the house. And this was about a 6,000 square foot house. The left side of the house was heating just fine. The right side wasn't, and they were blaming it on the controller, right? And I said, it's not the control. I had seen it. I programmed it. I was there. The house wasn't finished yet, so everything was working fine. But when they what happened was, and I didn't see this when they were piping everything in, is that next set of T's was about 6 inches away. So when you look at the water coming down, going down where that circulator is on the first left-hand side, all right, it was going out at 180 degrees, but it was coming back because it was injection at 110. That 110 degrees turned, went down the main primary loop and went right back down the next zone, which needed a higher water than 110, obviously. So because it was injection mixing in there, it needed a high temperature, but the max they had was 110 when the zone needed actually 125. So the right side of the house never worked until we separated it out a little bit further. So that 12 inches is super important to make sure you turn back into that smooth laminar flow and not the turbulent chaotic flow that you see there. Very important.
All right. What did we say about theory and practice, right? There you go. Excellent, excellent, excellent. All righty. So the 3 W's for closely spaced T's. The first W is what? It's your go-to ModCon piping arrangement. All right. Every ModCon boiler manufacturer out there will have this piping arrangement as your go-to piping arrangement. So the boiler would be up here. All right. That's your go-to. In most cases, it's going to work and work just fine. The key, of course, is to make sure your headers are big enough. And you can certainly oversize the headers. If your flow rate requires 1 inch, it's okay to go to 1.25 inches or 1.5 inches. In fact, it's probably a good idea because that will enhance the hydraulic separation. All right. So oversizing these headers is not a bad thing. When should you use closely spaced T's? Well, obviously a single zone repipe. If you're putting in a new boiler and the house just has one big zone of convectors or cast iron radiators or whatever, this is going to work and work just fine. If you have multiple zones, this will work with a multiple zone system as well, as long as each one of those zones, the heat load of each one of those zones is higher than the boiler's minimum firing rate, its lowest turn down ratio. If each one of those zones is larger than the boiler's minimum firing rate, this will work and work just fine. Okay, so there's your when. And then your why, simple. It's a simple piping arrangement, and it works in most applications that you're likely to run into. All right, so there's the what, there's the when, there's the why. All righty. So we're timing this almost perfectly, Dave. You know why?
Why's that?
It's Takeo trivia time. Are you ready? Ooh. It's Takeo trivia time. And Dave, what kind of a gift package do you think we're going to be able to put together? I know we have a new shipment of Takeo After Dark t-shirts that look El Spiffo, man.
That's right. We do have those Takeo After Dark t-shirts, but the if I remember correctly, what I have down in the garage, and I'm not there now, so I didn't go through the inventory beforehand, but I think I've got some Bluetooth speakers, job site speakers about this big, nice little Bluetooth speaker to go with it. I know I've got some camo hats, and I think I got some coffee mugs that I'll send out too. So I know that's going to be our big grand prize thing. Speaker actually sounds really good, and it's nice and small too. Of course, really small to easily leave on a job site and forget it there. But I will be sending that out for our grand prize tonight. And then after the grand prize, we'll give away a few other T-shirts also. So make sure you answer your question the best you can. And the right answers will go into a wheel, and we'll spin that off and raffle it off later tonight.
Very cool. All righty. So let's get to the trivia question, folks. Now, as you know, welcome back, Cotter. Mr. Cotter went back to his old high school to teach the sweat hogs because he, of course, was a sweat hog and he made good and he went back to teach at his high school, which is the whole point behind the song, the whole point behind the show. So the question is, in Welcome Back, Cotter, what was the name of the high school? It was in Brooklyn, we know that. What was the name of the high school in Welcome Back, Cotter? I know it. Do you, Dave?
I do.
You do?
Because I actually I didn't have it memorized, but I did have to go look it up because it's been a few years since I've watched an episode of Welcome Back, Cotter. So
there you go. How about, is Tim still with us? Tim, do you know the answer? Tim doesn't know the answer. Alan, how about you?
I'm going to be honest and say that I seen it when Dave was preparing, so I'm not going to attempt to answer.
There's a man with what's the word? I don't even know. Credibility,
Integrity.
dignity, integrity. That's the word. I have trouble with that word sometimes. Integrity. Yes, he's very integrious. All righty. So, what was the name of the high school in Welcome Back, Cotter? Okay, are we ready to get back to work?
Ready to rock and roll.
It's good that there's four of us because now we've got that could be us dancing, guys. Just showing the way. All righty, let's get back to work. Next on our list is, I wanted to share this with you too, because this is just one of those things that this was a complete accident. Our good friends at NTI, Jason, Ted, and Wheels, sent us out their ads for their Thirsty Thursdays. So we do Taco After Dark on Wednesdays. NTI does Thirsty Thursdays, which is just like Taco After Dark, but with a lot more drinking. Just check out the name of their show for tomorrow night. Tees, headers, or tanks? Oh my. There was no planning that was done on this. This was a complete and utter accident. So I encourage everybody to check out NTI's show tomorrow night and heckle, all right? Or just go see. I'm sure knowing these guys, they're going to do an absolutely fantastic job. They're three of the very best in the business. So it'll be fun to see how we stack up against the three of the best that are out there. So I just wanted to share that with you because I think that was really funny.
It was hysterical, man, because we sent out this email, went out on Friday, and theirs came out on Monday, and not like we talked to each other or anything. And they didn't even see ours. So that's the whole irony. John and I came up with this title, I guess, this is about a month ago that we came up with it. So it was one of those things that you got to be kidding me. So we've been doing these, obviously, since we've all shut down. And this is the first time we've gotten that close to doing this. So, and yes, I do hang out at a lot of the NTI classes. They have a good time. I know these guys for 20 some odd years already. So it's some good stuff. So check it out, everybody. So if you don't understand a thing that we said tonight, maybe they can make it clearer for you tomorrow.
There you go. There you go. Just sometimes things work out perfectly. This was terrific. This was terrific. All righty, let's talk about hydraulic separators and basically their alias low loss headers. They are one and the same. A hydraulic separator is a low loss header. A low loss header is a hydraulic separator, and the name says it all. It's a hydraulic separator. It's a big thing that hydraulically separates, or it's a header that is very low loss. You want to know what it does? Read it. That's what it does. Okay, it hydraulically separates. And here's a closer look at it. Again, your boiler supply, boiler return, system supply, system return. And what you have in here is basically everything the closely spaced tees do for you, but bigger and made for you. All right. It's a big open space in the piping, very, very low head loss to virtually none. The velocity of the flow inside here drops to way below 2 feet per second. So again, the flows are just completely separate. So this circulator doesn't impact what's going on over here, and what's going on over here doesn't impact that circulator or that flow. It keeps the flow, the boiler flow, separate from the system flow. It keeps the two completely isolated. And there are, you're going to see low loss headers out there. There's a lot of different ones, ranging from the very simple one that Taco makes called the HydroSep that's sitting behind Dave, and he'll show you that in a little bit, to some that will have a coalescence medium up here for air separation, and they'll have collision medium and a magnet down here for magnetic dirt separation. You'll see those more in commercial applications because they are quite expensive, but I think you're starting to see a few kind of move their way into the residential marketplace. But yeah, the collision medium or coalescent medium out here, like Paul rings, like in our 4900 air separators, would be set up here to collect many micro bubbles and absorb them and resorb them and shoot them out the top. And then the same basic Paul rings are used as a collision medium down below, and the magnet will grab any magnetic particles and bring them down here so they can be flushed out of the system. So yeah, you have those do exist out there. Okay, your basic applications for a low loss header, again, anytime the system flow is greater than the boiler flow. The system flow is greater than the boiler flow. Now here's an example. Let's say I have a 90,000 BTU zone, 90,000 BTU load out here on the distribution side, and I need 150 degree water. So I need 150 degree water going out, and my supply return delta T is 20 degrees. Real quick, here's a hint. There's that math formula. What is the total system GPM on the delivery side? And there's that hint, GPM equals BTUH divided by the product of delta T times 500. So 90,000 BTUs, what kind of a flow rate am I looking for at a 20 degree delta T on the delivery side? On the delivery side, what are we looking for here? Yep, you guys got it, 9 gallons per minute, 9 gallons per minute. That's, 20 times 500 is 10,000, 90,000 divided by 10,000, that's 9 gallons per minute. So obviously I need 9 gallons per minute over on that delivery side. On the boiler side, my manual tells me if I want a 40 degree delta T across the heat exchanger in that boiler, the required flow rate I'm going to need for that circulator is 4.5 GPM. So you'll see the delivery side flow rate is twice the boiler flow rate. So what I want is this flow at 4.5 gallons a minute, and I want this flow at 9 gallons a minute. Now you'll note there's going to be some mixing here. And you don't even have to do any math here to figure out what temperature I need the boiler to be set at. Because let's think about this. If I've got 150 degree water going out and my delta T is 20, what water temperature am I going to have on the return of all of these? It's 150 going out, 20 degree delta T. My return water temperature is going to be
130.
130, yes, it's going to be 130. So 130 is going to be coming back. I know I want that boiler to work at a 40 degree delta T. So what's the temperature coming out? It's going to have to be 170, right? Okay, so I've got 170 going out, 130 coming back. There's my 40 degree delta T across the boiler's heat exchanger. So I'm going to have mixing going on in here. I'm going to be mixing some 130 with some 170 to get my 150. Okay. And there's algebra for that if you really want to do it. I could show you the algebra, but not on a Wednesday night. Okay. I want you to get out a bottle of brown liquid before we do that. All righty, very good, very good. Now, the 3 W's for hydraulic separators. What is it? It's a packaged, closely spaced tees plus some mass. Okay, that's what it is. It gives you some water content, okay? And it's basically your closely spaced tees packaged. All right, it's packaged for you. When would you use this? Well, you'd use it, that mass comes in handy when you have multiple zones that are approximately the same as the minimum boiler firing rate. They're kind of close, okay? They're higher, but they're pretty close, you know, higher than or equal to. They're fairly close. And the why? Well, it gives you that little bit of mass, but really the biggest thing here is it's space and convenience, right? So the other part of that when might be, hey, I got a really cramped mechanical room. Okay, I got this thing that'll do all of this stuff for me. It's pre-made, it saves me time, it saves me space, it saves me labor. I can put all this stuff together in one simple pre-made unit, right? Take me a quarter of the time to install. It's convenient, I save some space, and I keep that hydraulic separation when my have multiple zones that are approximately the same as my minimum boiler firing rate. Okay, any questions out there, Dave, that we need to address?
I don't know. I've been typing names in.
Oh, that's that pounding I'm hearing. Okay.
Yeah. Oh, sorry.
Okay. The question, well, there's a good question from Douglas Martin. How do you size one? In these kinds of things, I hate to say it, but size is kind of doesn't really matter. If you just are using it for a convenience item, size really doesn't matter. And we have a couple of small, simple ones that get the job done. If you start getting into, you know, really larger applications, the pipe's bigger, and by definition, the canister will be bigger. Okay. And then the ones where you have the collision medium and the coalescent medium, they get a little bit larger still. Basically, what I've always done is size them based on the pipe sizing. You know, if I need 1 inch, I'll get one with 1 inch outlets, okay, or 1.5 inches, I'll get one with 1.5 inch outlets. It has to do with the outlet size piping that I need. And here's the other good thing is you can't oversize these. You know, you undersizing them possibly, but you really can't oversize them. Not sure that's the best answer there, Douglas, but it is the best one I have for you in terms of sizing them, because it's just what you look at the pipe sizing basically. All righty, very good, very good. Now let's talk about buffer tanks. Buffer tanks are big hydraulic separators. All right, buffer tanks are big hydraulic separators, and it's all about the mass, baby. We need water content for these applications. The reason we use these is because we have a very specific set of circumstances that we're looking at. We have a low mass boiler, and we have a lot of zones. We have a lot of zones, and they're small. Radiant systems come to mind in particular, where I've got a lot of really small zones. That's when we want to look at buffer tanks. We need that mass to make sure we minimize short cycling, reduce short cycling, minimize short cycling for that low mass boiler. All right. And again, as I said, it's the same thing as really, if you look at that, it's a big hydraulic separator. It's a big old tank. All right. That's all it is. It's a big old tank with 4 holes in it. You know, boiler in, boiler out, system in, system out. All right. That's all it is. It's just a big old, in this case, insulated tank. And as you can see right here, there's a lot of ways to control it. There's a little tapping there that could be used as a sensor that goes back to the boiler, and the boiler controls the temperature in the tank, which is when you get into larger tanks is really the smart way to go. All righty. So here's your piping schematic. As I said, it's no different than a low loss header, just bigger. All righty. The question here is, how do you size one? So your question the question you asked earlier there, Douglas, actually is more applicable here than it is with low loss headers. How big of a tank do I need? Now, again, I'll say this: bigger is not going to hurt you here. All right, it's impossible to oversize one to your detriment, other than cost and space and that kind of stuff. But in terms of functionality, you really can't oversize one. And even undersizing a little, once we understand what we're trying to do, doesn't hurt us all that much. So let's take a look at sizing, and then we can get into the what's and whys. Well, let's talk about the why first. Really, again, you've got a boiler here that has very little water content, right? Whoops, sorry. You've got very little water content here, and you've got a turn down ratio that'll go down to a minimum firing rate. If I have a lot of zones over here where the load on one of these zones is less than that boiler's minimum firing rate, what's that boiler going to tend to do? Well, it's a boiler that wants to short cycle already, and when we have micro zones on this, we're going to put that short cycling into overdrive, And really what we've done is we've just planted a ticking time bomb in somebody's basement. Something's going to go wrong with that boiler from turning it on and off and on and off and on and off and on and off like that. So we want to, and not only that, that boiler's never going to be as efficient as it could or should be, not even close. So we want to make sure, A, that the boiler operates at its peak efficiency for as much of the time as we possibly can get it to do that. And we want to protect it from having premature failures of different parts, pieces, and components. All right. So how do we size one? 3 very simple steps. Step 1, you want to find your minimum boiler firing rate. Whatever the turn down ratio is, what's the minimum boiler firing rate for that particular unit? Once you find that, then you need to find the BTU load of the smallest zone. So minimum boiler firing rate, and from that, you will subtract the BTU load of the smallest zone, the smallest zone. So minimum boiler firing rate minus the BTU load of the smallest zone is going to give you something called the BTU surplus, the BTU surplus. That's step 1. Step 2, we want to multiply that BTU surplus times the desired minimum runtime. And we target that at 10 minutes. That's what that is that's us saying, hey, every time that boiler fires, I want it to fire for at least 10 minutes. That way I know I'm going to get above the steady state efficiency line, and that boiler is going to be spending most of its time operating at its peak efficiency, its peak combustion efficiency. So that's why we choose 10. So BTU surplus times your desired minimum runtime, again, typically 10 minutes. That's going to equal something called the cycle factor. We call that the cycle factor. Step 3, we're going to divide that cycle factor. We're going to divide the cycle factor by our old friend delta T times 500. And that's the delivery side delta T times 500. So if it's a standard conventional residential hydronics, we typically design to a delta T of 20. So it would be 20 times 500 if it's 100% water. If it's glycol, obviously that 500 would be a little lower. Residential radiant, in most cases, residential radiant would be designed to a delta T of 10. So it would be 10 times 500 if it was 100% water. So we'd need to make sure we knew what we were dividing by over on that side. So cycle factor divided by delta T times 500 on the delivery side, that will give us the tank capacity in gallons. All right. Takes longer to explain than it does to do. Like most things in life, right? Takes longer to explain. So let's walk through one real quick. All right. Let's do one together. Let's say I have 150,000 BTU ModCon with a 10-to-1 turn down ratio. If I have a 10-to-1 turn down ratio, what's my lowest firing rate? What's my lowest firing rate? Let's see what you got. Yep, 15,000, all right? That's 15,000 BTUs. That's my lowest firing rate. All righty, next. My smallest zone is 5,000. So my minimum firing rate is 15,000. My smallest zone is 5,000 BTUs. It's a radiant floor heating system, residential radiant floor heating system. Smallest zone is 5,000 BTUs. So 15,000 minus 5,000, that gives me a 10,000 BTU surplus. That's what I got extra. That's what I got to buff with. I got to buff that. I have to buffer that. There we go. So 10,000 BTU surplus. If I multiply my BTU surplus times my 10-minute minimum runtime, I come up with a cycle factor of 100,000. All right, so 2/3 of the way through. So 10,000 BTU surplus times a 10-minute minimum runtime, I get 100,000 I get a cycle factor of 100,000. And finally, to size the tank, I'll divide my cycle factor by my delivery side delta T times 500. Now remember, this was radiant floor heating, so my delta T is 10. So it's going to be 100,000 divided by 10 times 500, or 5,000. That means I'm going to need a 20-gallon buffer tank. 20-gallon buffer tank. There are plenty of companies that make buffer tanks. Well, what if you're looking around and you can't find a 20-gallon buffer tank? You can only find a 15-gallon tank.
The
Does that mean
horror.
I know, wham, wham. There's no crying in hydronics, okay? We're not going to call the wambulance. There's no crying in hydronics. You use a 15-gallon tank. If that's what you can find, that's what you can find. Use a 15-gallon tank. Dave, what's the worst thing that's going to happen if they put in a 15-gallon tank instead of a 20-gallon tank?
You get like an 8-minute runtime instead of the 10-minute runtime. That's
And the
it. Yep.
the hydronics police will not come and take you away. All right. It's okay. It's better than what we would have had. It's not perfect, but it's better than what we could have had. Well, what if you can't find a 20-gallon tank? You can only find a 30-gallon tank. That's the only one you can get, a 30-gallon tank. What are you going to do? We'll put in the 30-gallon tank. Dave, what's the worst thing that's going to happen there?
Now you get a 15-minute runtime, so it just runs a little bit longer. That's it.
There you go.
The BTUs will be stored for you to use.
That's right. That's right. So again, it's impossible to oversize this tank. Again, cost and space are the two big limitations, obviously. But if you can only find a 30-gallon tank, you put it in. Hey, we're going to have a longer runtime. If you can only find a 15-gallon tank, hey, put it in. We're not at 10, but maybe we're at 8, and that's better than we would have been if we didn't put in the tank at all. Okay, so that's the whole point behind the buffer tank story. All right, and again, why do we do this? What are the 3 W's? Well, what it is again, we said it's a really big hydraulic separator. All right. When do you use it? When you've got a lot of zones that are smaller than the lowest boiler firing rate. We don't want that thing to short cycle. We're talking about micro loads. We're talking about radiant floor heating systems primarily. There may be other instances where you want to use them, but we see them most with radiant floor heating systems. All righty. And why do we do it? We want to maximize the efficiency of the boiler and minimize the ticking time bomb that is short cycling. All right, that's what we want to do. And in my mind, this isn't, if you have micro zones, this isn't optional. I think this has got to be standard installation procedure. I've had a lot of folks say, yeah, but that's going to drive up the cost. Yeah, but so's doing it right. I mean, so's connecting up the gas. That drives up the cost, but you wouldn't think of not doing that. So it's just it's a matter of doing it right and not accepting fine. All right, you don't want to accept fine. It'll be fine. Yeah, it's going to work. They're going to deliver heat, but in about 4 years, a blower motor is going to go. An ignition module is going to go. We might have heat exchanger issues. That's not normal. Okay, that's not supposed to happen. All right, and usually it happens after the warranty period, and they say, isn't it a shame the really crappy components they use in these things these days? The components are just fine. We just short cycled them into an early grave is all. And then any money they may have saved on fuel over the 4-year period is now poof, gone because we didn't put in a buffer tank. And we short cycled a very expensive key component into an early grave. Okay? That's why we think about these things. That's why we want to look at buffer tanks and things like that. All righty. Awesome. Couple questions that came in. Dan said, could an electric water heater be used if the port's allowed? I suppose. I mean,
you're looking at an electric water heater, 2 ports. It's a 2-pipe buffer at that point, not a 4-pipe. Right. So your drawings were showing 4-pipe, and now it's just a 2-pipe buffer instead. Yep.
Yeah, unless you take out the drain and you don't really have another.
You don't have a third.
Yeah, it'd have to be the drain and the relief valve ports to make it a 4-pipe. But they're not really. They're not really. They're not really placed strategically.
Right. That's where it works better with just making it like a 2-port, a 2-pipe buffer. Yeah, in and out. Another couple of questions that came in before, a little further up the list there, is so Chris Warner was asking, do buffer tanks still allow condensing to occur?
Oh gosh, yes.
Oh yeah, I mean, because you're going to have that outdoor sensor still hooked up, so it's not necessarily firing at 180 degrees all the time. Now remember, please do hook up those outdoor sensors, and if you run to a job site that does not have that boiler sensor hooked up, do it. Get your hands on the sensor. It's probably in a box behind the boiler somewhere. And hook it up, because talking to a lot of the boiler manufacturers out there, the experience that I've heard out there is about 40% of ModCon boilers on the wall do have the sensor installed. That means 60% do not have it.
Wait, what? Run that by me again.
60% of ModCon boilers do not have the outdoor sensor hooked up.
That boggles the mind. It
Yeah,
really does. Because why
it
would you?
does.
You're putting this thing in because it can run at a low water temperature, and you do want outdoor reset to maximize the efficiency, right?
Yep. Well, I hear it a lot, and it's to eliminate the return phone call, the return job site visit, because something's not working properly, or they don't think it's working the way it was, because the boiler that was there before was the big old cast iron behemoth that banged off at 205 degrees all the time, and now you got a boiler that's doing a low temp. And I had it happen in my own house. Well, not my house, my in-laws. So they had their original 47-year-old boiler in the house, time to go. So I went and threw in that wall hung ModCon boiler, modulating circulators, and did the work over the summer. So we were in a dead boiler, so we had plenty of time, but I did it. And the following winter comes along, and I knew I was away on the road for a few days, and my mother-in-law, my wife was going to my in-laws' house. So I gave a call over there to talk to my wife and said, oh, Mom, hi, how you doing? And, oh, by the way, how's the heat? Because this particular trip when I was away happened to be the first cold snap that we had in November. Sure, there was a need for heat all along, but all of a sudden, yeah, we really dropped in temperature. And she's like, oh, yeah, I've been meaning to ask you about that. I don't think it's working. And here I am on the road for the next 4 days, not coming home. And I just know the temperatures were dropping all week long. And I'm sitting here thinking in 3 seconds on who I can call to get to come over to the house. And I said, okay, all right, hang on a second, Mom. What do you mean by it not working? And she says, I said, what's the thermostat set for? She's like, well, it's set for 69 degrees. And that's where we're comfortable at. Okay. What's the temperature in the house? It's 69. You do the math and I'm like, that's working. What do you mean it's not working? And she's like, I don't hear it anymore. Because here she was used to that boiler banging on and off at 205 degrees, the baseboard going tick, 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 and hearing the fire of that boiler going off and all this other jazz. And now all of a sudden, everything was silent. I never explained it to her. I never said what the difference was going to be. I just said, hey, we're going to put this new stuff in. It's going to modulate. We'll save some fuel, blah, 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 blah. And I left it alone. Never went any further with it. So, sometimes, people don't want the phone call, so they don't hook up the outdoor sensor. Or
Yep.
What temperature do I program it to? Because if you leave the defaults, the reset curve of the boiler is way too steep, which means on a 68-degree day, it's sending 68-degree water out. So you got to make sure you change the parameters and understand what the low end of your heat emitters should be able to see, especially if you're doing it to a high temp system like baseboard, fan coils, cast iron radiation. We need to understand how low you can go, or even what is the low temperature to be your high. Doesn't always need to be 180. So some guys just don't program it and take the sensor out, and this way it bangs off at 180. So I can understand that. That was
There
a
you go.
really long story, wasn't it?
It was a very long
After,
story.
Chris asking the question, do buffer tanks still allow condensing? So,
Yes.
yes, it is. Man, sorry, if I go off on tangents, you got to make sure you drag me back.
You got to reel you back in. There you go. That's all right. I just made myself another cup of coffee while you were talking. No worries. I was going to walk the dog, but I figured you'd be done by then. Where do you, Jeff House, how do you do, Mr. House? Where do you put the system sensor to tell the boiler when to recharge the tank? In the tank or on the return from the system going back to the tank? I'd say in the tank. In the tank would be the best. If there's a well for it, and most of them do have a well. The reason you want to do that is, hey, if the tank is charged and there's a call for heat, again, the whole point behind doing this is if the tank is charged to the right temperature and one little zone or two little zones are calling, you may be able to satisfy those calls for heat just on what's in the tank, right? And you're not firing the boiler. So now, efficiency doesn't get any better than that. If you can satisfy a call for heat without the boiler even knowing there is one, man, that's about as good as it gets, right? So that's the ideal, in my opinion. Okay, that's the ideal. Let's see what else. So Bob O'Brien says setback thermostats are a major cause of disconnected outdoor reset. Yep. Hey, it's not coming back quick enough. Oh my God, just leave it alone. You know.
Right.
That may be a battle we never win either. You know.
That's a major battle right there when you think about it. And that goes along with the same story with my mother-in-law, but they never did setback in their house. They didn't want to learn how to program it, so that was fine. But deep setback, we've been told for decades from the government on how you're going to save energy. Lower the thermostat, 10 degrees. No.
Oh, that's what they meant by lower the thermostat.
Right.
I moved mine down 2 feet. When they said lower the thermostat, I thought it was I put it 2 feet lower.
Right. It works better that way too. Right next to the baseboard. It shuts off. Yeah. Now, for those of you that are
right there, Dave.
So if you are looking at putting in a ModCon boiler to your house, and we learned this in an earlier episode of Takeaway After Dark about a year ago, and somebody said it during the class, they said, if you tell somebody beforehand, it's an explanation. If you tell them afterwards, it's an excuse.
Right.
All right. So when you are starting to put this boiler in, discuss how they're going to use it upstairs, because remember, their only interface to the boiler is from the thing on the wall upstairs. They have no idea what we do downstairs, so they need that thing to operate the way they want it to. So tell them, sure, you want to go setback, don't go deep.
Right.
Don't go deep. The reason why you use setback is for efficiency. Okay. Well, heck, we just put this boiler in that is supposed to be as efficient as it can be. All right. By doing those deep setbacks, just think as we cool it all the way down, now we got to heat it all the way back up again, meaning the house. So there's not a huge amount of savings that you're going to see there. Yes. When's the boiler most efficient, John?
When it's off.
There you go. Right. So yes, use it, but just don't abuse it. Okay.
Right.
Do a couple of degrees. Yeah.
No more than 3 to 5 degrees, no less than 5 hours. 4 to 6 hours, I think, is generally a good rule to live by. This goes back to something my Italian grandmother taught me when I was a bambino. She would look at me, she had like a meatball on the fork, and say, "Giovanni, look at me. It's easier to clean a room than it is to clean a dirty room." Do you see what I'm saying? No?
Yeah.
It's easier to clean a room than it is to clean a dirty room. By the same token, it's easier to heat a warmer room than it is to heat a colder room. Huh?
Capiche?
Capiche?
That's it.
Philomena knew what she was talking about. That little old lady with nylons bunched around her ankles from Avellino, Italy, knew what she was talking about. And
That's
boy,
right.
could she cook. Boy, could she cook.
You had me at the meatball.
Yeah. Does the condensing temperature change at altitude? Asked Scott. Boiler guys, what say you? I'm going to throw this one to Alan.
I'm sorry, say the question again.
Does the condensing temperature change at altitude? We know output changes at altitude. You have to derate boilers at altitude. Does the condensing temperature change at altitude?
Well, I honestly don't know if the actual temperature would change. It's kind of I want to think of how I want to say this, because first of all, I'm not 100% sure that I even have the answer. But
That's
it's
why I
long-winded. Let me just say this, because indirectly, it does affect it, in my mind's eye anyhow, because when there's a change in atmosphere, there is a change in your gas pressures, which is going to change your BTUs, which is going to affect your temperature of water, which is going to affect your condensing.
Yeah, I know we know Bob O'Brien says
that's probably answering the gentleman's question.
Yeah.
I don't think specifically, but if you look at the whole picture, then of course the atmosphere the whole system is in will have an effect on it.
Yeah. Bob O'Brien said the boiling point is lower, but the condensing point is not. It's still right around
Right.
127, according to Bob. And again,
Yeah.
that's something that's something that I will defer to Bob because Bob is a smart guy. So we'll look that up. I just want to confirm what you're saying, Bob. Not that I doubt you, but I always like to look that up and see for myself too. So that's good stuff. Alrighty, real quick, let's get the trivia answers here. And then then we want to take a quick tour of Alan's facility so you guys can see this. So it's time to answer our trivia question. All righty. And the answer is the James Buchanan High School. That was the name of the high school in the show. A lot of you folks had New Utrecht High School, the New Utrecht High School in Brooklyn. Gabe Kaplan, the actor, went to that high school in Brooklyn, and the whole show was based on the New Utrecht High School, but the name of the high school in the show was the James Buchanan High School. All right, and there's my graduation picture, 1970, class of 70. Well, I was class of 78, but Vinny, of course, was in the advanced class. He was supposed to graduate in 79, but they kicked him out in 78 and said, here, just take your diploma and go. All righty. So yeah, Rich McGrath says, damn Googlers. You Googled it, but you Googled the wrong thing.
And it was getting me too, because I'm seeing all these answers coming in and I'm just like, wait a minute. And they're all coming in as not a lot, but I mean, not all of them, but a lot of them came in as New Utrecht. And I'm like, all right, now I got to go spend some time Googling this myself and figure out what's going down.
Yeah.
So, cause it was way too, if it was one, it was another story, if you typed in Bensonhurst, Tossie, then, you were just drawing straws,
Yeah. Chris Warner actually has a good has an interesting point. In the 70s, Brookstone did a survey and stated that 8 hours or less, 5 degrees for 8 hours, or more than 7 degrees. Otherwise, it costs more to bring it back than you save. So yeah, pretty much what we're saying. Yeah, and that's it. Okay, I'll get a hold of that survey too because that's good information. Thank you for that, Chris. All right, cool. All righty then. So we're on to next week. And next week is going to be, I think, we're bringing back one of our most popular programs ever, is the importance of residential boiler water treatment. Why you should treat your boiler water, how you should treat your boiler water, and what are the different ways of doing it, how to test it, what kinds of things you're looking for. And we're really, really lucky to have a special guest presenter. This guy does the very best presentation I have ever seen anywhere on any planet on boiler water treatments. His name is Patrick S. And there he is right there. Patrick S. from Mondale and Associates, a manufacturer's rep out in Minnesota, will be joining us as a special guest instructor. And you will not want to miss this, folks. Tell all your friends, get as many people as you can, because this is maybe one of the most beneficial things you'll be able to do on a Wednesday night in February. So hopefully we'll see it. We'll see you all there. But that's going to be an awesome program. And I think he'll be wearing a cape, if I'm not mistaken. All righty, very good, very good. So I'm going to stop sharing my screen. And Dave, I don't know if you want to take a good give the folks a view of what's going on in your stop showing screen. There we go. Okay.
Well, before we do that, let me give stuff away.
Oh, we have to give stuff away. There we go.
So I am sharing. I'm going to share my screen.
Okay, Juan Epstein.
All right, how's that for Juan Epstein?
Oh,
how do you like that picture? All right, so what I did do is those of you that did answer New Utrecht High School, I threw you in there too. So I'm being a nice guy, so I did put those answers in too.
Guy.
Because it was
yeah.
It was
he's a suck up that
question, so I threw everybody in there that also put in New.
Vague. What is the name of the high school in Welcome Back, Cotter? That's not vague.
So
that is not a vague question.
It wasn't vague, but I could understand them getting it wrong. So, or not proper. How's that? I'm not going to say wrong, but
no, it was. Right. I think it was just incomplete Googling. That's all I'm going to say.
Okay. All right.
Go for it. But I support your decision.
Okay. All right.
Rich McGrath does not, however.
All right. Well, he's won so many times. If he wins now, then. And we're going to land on Mr. Eric Hoffman. There we go.
All right, Eric.
I have your contact information. If you registered with it, I will make sure you get your grand prize sent out to you. So greatly appreciate it.
Give away a couple more T-shirts?
Most definitely. Most definitely. So we'll pull Eric out of there and we'll do another spin. And let's see here. And Mr. Dan Clemens.
All right, Dan. Congratulations.
Mr. Minnesota, good to see you. I only know that. I don't remember the name of the town, Dan. Sorry. But I think I remember where you are.
I think he's about 80 miles southwest of the middle of nowhere.
Scott Jones.
All right, Scott.
All right. And let's do one more. How's that?
All right, one more.
Okay. And one more. And Charlie Huss.
Congratulations, Charlie.
I'm just writing everything down, and I will be sure enough to try to get those in the mail as soon as I can when I get home. So perfect.
And you can feel good about wearing these T-shirts too. We got them from an organization in Minneapolis that it's a program for at-risk teenagers and homeless kids, basically. And what they do is they teach them life skills and job skills. So part of the job that they're teaching them is how to run a business, in this case, was how to run a T-shirt business. So they write up the business plan, they find the funding, and they do all the sales and marketing and do the printing and shipping. So that a friend of mine is an administrator of that program. We decided if we're going to buy T-shirts, we're going to buy them from those guys. Yeah, Elpis Enterprises in Minneapolis. And figure if we're going to give them away, let's make it for a good cause. So these are shirts you can feel really proud about wearing, because they're not only are they cool looking, it is a good cause. All right, I'm going to turn my camera off, much to the delight of everyone, so we can see what Juan Epstein has up there.
All right, so hopefully you guys can still hear me. Actually, I should probably change my microphone, but let me bring this over to here so you guys can see what's going on. So based on the class today, and that's why I thought about doing and Alan and I were talking about doing it from down here tonight with these particularly behind us is, hey, look what we got right here. Couple of closely spaced T's piped in with this boiler here, right? So that's what we got going on. This boiler happens to have an internal circulator already installed. So, and then this is just coming out, going to our air separator, going off to a zone, and coming back from that zone and coming back into the boiler again. So, so there's your closely spaced T's tied in, and yeah, as close as you can get them, man, as close as you can get. And then we jump over to here, and now with the NTI boiler, we've got our pipe coming down, following along, going into our hydro separator. All right, now with the hydro separator from Taco is this complete unit, even with these brackets. So one of the things that's important with the hydro sep is to not go and cut this pipe whatsoever. You're going to leave it the length all the way out to here, because the volume of all that water is added to it. So here's your boiler side coming in, and those are your heating sides going out to the system itself. So, so what we've got here in this lab is just showing lots of different ways to pipe, doing some hands-on, and then coming out of it, we can see that we tied this into a 3-zone system, a couple of circulators up on the wall over here, and then they're going up, and then we've got there's actually a dump zone up on the roof on the air handler. So those two pipes are tied in. Again, closely spaced T's into the system going out, and it goes to a big air handler to do a dump zone. So when they're training and they're learning in here, they can actually also, if you look down low at the pipes, they can go between setting up this boiler with propane or natural gas also. All right, so that's also another cool thing, getting some really hands-on, doing your combustion analysis and setting the boilers up properly. We've also got ourselves in here a big old burner, a big old commercial Burnham boiler. All right, you can see behind the chair. So guys are really setting this thing up, making sure it's up and running properly. Going up to some big 2-inch pipe, using one of our 0034E circulators as the zone circ, because you got to put a lot of flow through this thing. Jumping over to this side, I got to make sure that you can see what's going on. And if there's any questions, go ahead, type them on in there. And if John sees them, he'll introduce, or read them out to me. So here we have an energy kinetics boiler. And all these boilers were donated by the different manufacturers. I'm sorry, let me jump. I talked about the Phantom already. Then you got the energy kinetics going out to one circulator with 3 zones out there with zone valves. And then a couple other boilers here from Crown, 2 cast iron boilers. And we were just showing different ways to pipe them in. Meaning the first one on the left-hand side is showing us with a ECM circulator and a spiral vent. And then over here, we have a basic scoop going up to zones with 2 circulators. And then over here, we have 2 zone valves on the other boiler. So, and then other things that they get involved in, getting involved in some furnaces and some heat pumps and mini split systems, doing some other hands-on training. So guys that are down here are kept busy, real busy, working and learning a lot of good things down here. So myself, what I did the last couple of days has been some advanced hydronics classes. So doing basically, take away the dark stuff and broke it down into about 1 day class. So we did a 9 to 3:30 event today.
Very cool.
It was actually pretty cool to be back live again doing training classes. Wow, it was tiring, man. Tiring to do a full day's training today.
I tell you what, that is kind of. If you haven't done it for a while, it's a totally different experience. Couple questions.
I've been used to 1 hour at a time.
Yeah, I know. Yeah, a couple questions came in. Well, one was, do you prefer pro press over sweat? And from my perspective, I don't care one way or the other. We sell both kinds. It's like, what's that line from the Blues Brothers? We got both kinds of music, country and Western, right? Doesn't matter to us. I see the point. I see the benefit of press. It's fast, and time is money, right? And you can always save more one by spending more of the other. And I think pro press has certainly proven itself. So I don't have a problem with it. I see, and I can see a tremendous benefit to it, especially if you have labor shortages and you need to get jobs done quick. That said,
John, could I add something to that?
Sure, please do. I think it was probably, that question was probably directed more to you than me anyway, Alan. So.
No, that's okay. I just wanted to add to that because interestingly enough, every time I bring someone in that room, I can't get out of that room without someone asking that question. And my answer is pretty consistent with what you had said. The only thing I want to add to it is the other value that the Pro Press brings is sometimes on certain jobs when you're doing an installation, especially if you're in a place of business, it requires pulling certain permits if you're going to be using an open flame. If you can go in and tell the building inspector, oh no, we're just going to do Pro Press, you've literally eliminated the cost of the permits for using an open flame and the potential of something happening with an open flame. So I just want to throw that out there because I talk a lot about that to the guys who ask the question when they come through our facility.
Let me do a quick poll of the group here, and I want the truth, people. How many of you have set a house on fire? I don't mean a 5 alarmer. I mean, oh crap, and you had that moment of panic. All right, I want the truth. Because I've done it.
I can tell you when I was in the trenches, I've in crawl spaces, I've been guilty of that, and thank God I was able to extinguish it.
Y'all left your mark, right?
Right. You left your mark, yeah. As long as you extinguished it, yes. So that's why 5 alarm is we didn't extinguish it. I got out. Yeah.
That's right.
Yeah, Rich McGrath has a good point too. Pro Press does help with wet work, rather than grabbing a piece of white bread and sticking it in there and hoping it comes back out. You sometimes especially for plumbing service, if you can't get that water to shut off because you got an old stop somewhere, press can save your butt.
Yep.
And
Very
you
good.
know, there's nothing wrong with you know, with progress and changing technologies or using new stuff. Otherwise, we'd still be using galvanized and brass pipe.
Yep.
Right.
You know,
And
so
yeah.
yeah, things are going to
My
change and doing lead wipes. Yep, lead joints and all. Oh God, yeah,
yeah.
yep.
My uncle, was a great old plumber and pipe fitter, and he was convinced that the trades, all skill left the trades when we went to PVC drain pipe. He said that was it. We're done as a society. You kids today, there's no skill left and this is back in this is the late 60s. So this is not a new phenomenon. This is not it's just the way technology marches forward. I look at it that way. And I swear the only time in my life I left my uncle speechless, because my uncle was a master needler. He would drive you insane to the point where with just his jab, 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 to the point where you're ready to just jump off a roof. The only time in my life I left him speechless was he was just complaining and said, you kids today, you have it easy. All you need to do plumbing today is a handsaw, a can of glue, and a level. And I said, Uncle Frank, who uses a level? Left the man speechless. He looked at me, his mouth was open, and he didn't know what to say. And that was my moment of triumph.
Yeah, I'm not related to you, son. I'm not related to you at all. Yes.
Let's see. Scott Jones says, I installed a Delta T Taco and the Navien Tech guys told me not to use them. The variable flow makes the boiler mad. Okay. Well, did you install, what kind of circulator did you install then, Scott? I'd like to know that.
Well,
Because if it's a Delta P pump, the flow's still gonna vary. So I suppose that'll annoy the boiler some too.
well, unless they're talking about as the boiler
The
pump.
boiler, right.
All right. As your zone pump, as your system pump, not a problem whatsoever. Do it all day long. All right. Done it many a times too. But as the boiler pump, it could be an issue because now you've got boilers starting to ramp up and then the circulator slowing down. And then all of a sudden the circulator speeds up and the boiler ramps down. So in theory, what you may see is you've got two drivers, one car, as things are starting to go back and forth, depending upon the technology that you got going on there. So, so your boiler pump sometimes, and depends upon the brand, it depends on the boiler, you do want it to go as fast as possible. But as a secondary pump, no, it wouldn't make it mad at all. It's got no reason to make anything mad to use a Delta T circ on as a zone pump whatsoever.
Or
It's going to send back the cooler water to the zones, and I mean to the boiler, and let it condense as much as possible.
Yeah, there's an awful lot of misinformation out there and bad information being spread about Delta T pumps from people who, for whatever reason, don't quite get it. I've had people say, oh, well, it's going to slow down too much and you'll get boiler water going backwards through those closely spaced T's. I said, well, how is that any different from, that pump going slow? How is that any different from a Delta P pump going slow? Those are two variable speed pumps and they're both going slow. That makes zero sense to me. Better to use your brain and size the boiler pump properly and not over pump with that boiler pump. Size that pump properly, and believe it or not, there's instructions, a little book that comes with every boiler they sell, and there's instructions in there and pictures and stuff that'll tell you how to size that pump. Like we should do another class on that. But yeah, that's some of that nonsense you hear about. Oh, well, that's going to make the boiler, that's going to, the flows will be too long and the boiler, it's not good for the boiler. People don't know. Some people just don't quite understand or don't get it, or a little out over the tips of their skis, I think, when it comes to pumping sometimes. All righty. What else do we have? All manufacturers, a solution, all manufactured use Taco OEM circs on their mod cons. Oh, Richard, I give you a big hug, man. Give you a big hug. Let's see. Do you have to use special press fittings with Glycol? Again, I can't answer, Eric. I don't, Alan, if you have an answer for that, or if anybody else has an answer for that. I know Richard says no. You do not. But again, I'm not an expert on the specifics on fittings. But Alan, if you have an answer for that.
Yeah, I won't say it's a definitive answer other than I have a lot of faith in the people who did the installation. And I can tell you, Dave alluded to a unit that we have that sheds the heat from all these boilers. That has glycol, and they did pro press into that. So, you know, I trust they did that knowing it was okay to do it.
Very good. Very good. Here's a question from James Sperenza. What temperature rise is too much for a mod con? Generally, it's going to depend on the model, but they'll give you a minimum, which I think is 20 degree delta T for the most part, and then they'll give you a range. I think the maximum I've seen is 40. I don't know. There may be others, guys. I don't know if you've seen any others that allow for a wider delta T than 40.
Some of the
That's the
boilers
biggest I've seen.
yeah, some of the boilers have the maximum delta T coming across there. If it's too high, it can start to trip out. So I have seen that on several manufacturers, and I know that only because it happened recently where they tried to start up a large snow melt. I'm sorry, commercial building. It was a garage. I'm sorry, not the snow melt, but it was a big garage, and the boiler didn't like it. Because they started it when it was cold. It was just as cold as it was outside, you know, with a 6-inch slab, and it had some huge delta T, and the boiler just didn't like it that much. So they had to choke down the flow going out to the slabs to slowly bring it up. It was going to take about a week. You know, they wanted to heat the building in 2 days. I said, I'm sorry, you're not going to get there. They're thinking the pumps were sized incorrectly. And I did the math like 3 or 4 times and said, yeah, no, the circs are fine. It was just the delta T across. And then as I dove into it a little bit more, it was the boiler didn't like the large delta T, and it was actually starting to trip out.
That would do it.
Yep.
That would do it.
And I don't remember, and Rich is saying, yeah, 58 degrees rings a bell. I don't know what those numbers were. Yeah, it was interesting.
Yeah, because when that water comes back from the snow melt, it's slush.
Right.
Yeah, and it's going to take a while to get up the temperature. Yeah. It is true. All right. Well, folks, keep those questions coming in. We'll stay on as long as you guys would like. We've had sessions earlier where we would go. Remember during the pandemic, we were on for 2.5 hours. Oh, heck, last fall we had a couple of classes we were on for 2.5 hours.
Yeah, most definitely.
Guys, if I may, I'm going to step out at this point. So again, I want to thank you for letting myself, PPA Tech and Oil Tech Talk be a part of this with you guys. I hope to join you in some future ones. And again, thank Dave and thank Takeo for him being here. I'm actually going to go. He's got another day he's going to do for us here. So while you guys kind of continue answering questions, I'm going to go get the classroom set up for Dave for tomorrow. So again,
Awesome.
Thank you. I love you guys. See you out there.
Same back at you, Alan. And thank you for all the work that you do. This is so necessary and so helpful for our industry, and we really appreciate it.
Thank you.
All right, take care.
Yeah.
See you, Bob. Excellent.
Let's see. Rich McGrath says, I think John Barba has his screen shut off because I might steal something.
He hasn't been able to see you all night tonight. I don't know why.
Really?
He saw my camera, but he can't see you at all. I don't know.
Huh? Can you?
But everybody else did, I believe.
Can you see me now, Rich? I'm here, man. I'm here. Just as screenshots. I'm here. I'm waving. Can you see me, Dave?
I got you fine, bro.
Yeah, I see waving. I guess must be something in New Jersey. I blame the Sopranos. What can I tell you?
I even saw. Oh, he saw you, just not the presentation. Okay.
Oh, you just saw me, but not the presentation.
It was weird. I don't know what was going on. He even logged out and came back in again, so I'm not sure.
That is weird.
Yeah.
Was it maybe it's one of those multiple screen things too, multiple monitors. Those things just drive me crazy sometimes. So.
Anyways, awesome, everybody. Thanks so much for coming by. I'm not saying goodbye or anything like that. It's only 8:30 at the moment. I've got nowhere to go except for a hotel room, so I can more or less stay on as long as you guys want me to. I know there's a diminishing return in trying to stay on after 8 o'clock at night, and the brain just can't take anymore. I understand that too. But if you got any questions whatsoever, please do not hesitate to ask John and I what we got going on. Al, anybody online here with us make it out to the ASHRAE show? Did you get to AHR? Did you head out to Vegas this past January or early February, I think it was. Let me know if you guys went out there. I was
Yeah,
not
we
there.
did.
John was, but I did not get there. So that's also why we started this week, because we had a lot of work to get stuff going for the AHR show. So everybody was really super busy getting prepared for
Yep.
that.
Yep.
So we wanted to
Yeah.
make sure that we introduced this afterwards.
It was a pretty good show. I got to tell you, if, it was good to be back in a show environment, even though, we had to wear masks inside the whole time. And that was, it was fine. It was fine. It was no big deal. And, having it in Vegas was kind of cool because that's always the city that never sleeps. We went to go see the Beatles Cirque du Soleil Love Show, which was unreal. That was amazing. I'd highly recommend that. So that was a lot of fun, and we got to see an awful lot of old friends and new friends, and talk to an awful lot of people. So that was definitely well worth it. And other news, I guess, for you is, we are our factory training schedule should be going public fairly soon. We're going to have a handful of classes at the factory this year for 2-day programs. And also, I think I'll throw this out there for you guys. Also, I think we're going to take the factory show on the road. We were just kicking that around today. I think that, let me ask you guys, if Dave and Rick and I came to your town and we were there live for 2 days, would you want to come see us? If we came to your town in our traveling road show, would you want to come see us? So we got a sure from James and a yup from Dan. So there's 2. Okay, we'll put you guys on the good column. No one's saying no yet, so that's good too. So okay, good. Monmouth County, New Jersey. Then you can see the presentation and us there, Richard. Yeah. But yeah, that's something we're kicking around today, and we got some partners very interested in hosting that could make this a lot of fun. So I think we might have to look into making that a reality, because we don't travel enough, Dave.
I know. Well, like I said, whether I'm in Pennsylvania or Pensacola, I'm still traveling.
There you
Yeah.
go. There you
Right.
go.
Yep.
And so I think we should be, if we take this show on the road, I think I have some ideas where we should go based on activities nearby. I'm not saying, I'm just saying. Okay. You know what I mean?
I do know what you mean. Yes.
Do know what you mean, yeah.
Mhm.
And this will be good because we also have our new air to water heat pump that we have to meld into the program. We showed our new System M air to water heat pump at ASHRAE or AHR, and that should be coming out. If you guys are into air to water heat pumps, this is a pretty interesting niche solution that should be coming your way starting in June. That will have units ready to go. And if you get ProPress, here's the thing: if you get the value of ProPress, you will definitely get the value of the System M. And I'm just going to leave it at that.
Okay.
If you get
Gonna leave it hanging, aren't you?
yeah, if you get why ProPress really makes a lot of sense, bang, then System M. If you're into air to water heat pumps and low temperature hydronics, heating and cooling and domestic, you're going to find something pretty cool. You're going to find this stuff pretty cool. Eric Hoffman, help with a pump 20 feet ahead, 12 gallons per minute. If it's ECM, that sounds like a 26E, doesn't it, Dave? I think we get
that I'm not sure of. I'm looking at the AC version, and right now you're looking at a 0011.
okay.
Is going to be that pump right now, 0011 or a 0013 circulator. 00, I don't think I have. Let me see here.
Yeah, the 26. Yeah,
12 at 20 could
that should be right in the
be
wheelhouse.
26E and the 34E. Yes.
Yeah. So I'd say the 26E or the 34E for the high efficiency ones would be definitely in those wheelhouse. And we're going to be back in the 26E and 34E business by April, May, I think. That the worldwide supply chain is affecting everyone. And for us, it actually put us out of the 34E and 26E business for several months because we simply couldn't get the circuit boards for them. Just the way it is. But we're back We're making them now, and they should be ready for shipment probably late April, early May. I think that's where we were at there, Dave.
As far as I know, correct. Yep.
Yep. And yeah, the 34 is we'll do 0 to 10. The 0034E is a 0 to 10 volt pump, so that'll work. That'll work on that. And the 34E's got a bunch of different operating modes. One of them is 0 to 10. So cool.
Awesome.
Very cool. And Rich says he's going to try a 0026E with the Ranco 1 to 10 or 0 to 10 volt controller to make it a Delta T circulator as soon as possible. I love it. I love it. I got to tell you, I am taking a trip to the UK in the end of April, and I'll be attending a school there, a hydronics school, to learn about hydronics in the UK. Taking a vacation there and figured, what the heck, let's mix in a little work, because when my wife and I go anywhere on a trip, I'm always looking at the radiators anyway. It drives her nuts. But I'm going to be going to a 2-day school in Northampton, England, and I want to learn all about how they do hydronics over there, because it is a little different. Again, the terminology is way different. But one thing I have learned is a lot of folks in our industry tend to think those Europeans know everything, that the Europeans are so far ahead of us, they're so far advanced, they know everything about hydronics, and we're just a bunch of knuckle dragging, Americans. And nothing could be further from the truth. There's a crying need for education over there as well, which is why this school was set up. And one of the things they're asking for over there is a Delta T pump, because they understand the importance of Delta T in making sure air to water heat pumps work effectively, making sure boilers work effectively, and making sure systems are comfortable. So it's just a very interesting dynamic over there, and I'm really looking forward to learning more about it. And maybe we can do a Monday night live from the UK, Dave.
Oh, that sounds interesting.
Yeah, maybe I'll do it from the school, because we will have. But they're 7 o'clock.
5. It's 12 o'clock there.
Yeah, so 7 o'clock. There's going to be midnight, so I'll have to do it from my hotel room. That'll be okay.
All right. Well, we'll just have to do it earlier in the day.
Yeah.
That's all.
Or we can. We could do that. We could do that. But well, I'll definitely do some live. I will definitely do some videos and stuff from over there for everybody. Yeah. Right, Rich. Is there a benefit to use a buffer tank on an oversized oil boiler, 150,000 BTUs with only one zone of heat, less than 40,000 BTU load zone? Yeah, I'd think so. Yeah.
That's the same calculation that we just did. Hey, you don't have an oil boiler that's got a turn down ratio, so that is the lowest firing rate.
Yeah.
Right.
So you've got a 90,000 BTU surplus.
Yep.
All right. So let's do the math. 90,000 times 10 is 900,000. Divided by 10,000, that'd be a 90-gallon tank.
To get you a 10-minute runtime. So yeah, and it's just, and it's a cast iron boiler, so that's interesting, because you do have a large water content too. And it's going to sip the BTUs out of that thing. The best, I think the first thing you should do is put that boiler on outdoor reset. Do some modulation with that boiler so it's not firing to 180 degrees all the time. So I think that would be the least expensive option to do first, because a buffer tank is now going to add a lot of dollars, a lot of work to the system, whereas an outdoor reset control is just wiring, no cutting into the system itself. And I think that'll help out. And that boiler won't always do that 150,000 BTUs. Yeah.
And if you really wanted to get fancy, do that. Widen the differential. If the differential is adjustable, widen it. All right. and then go with some delta T pumps too, if that's you want to take it to the next level. And that'll help with the sipping thing. If you widen the differential and then have that pump sip BTUs out of that boiler, you'll get into that. You'll kind of emulate a buffer tank. I think you'll use the cast iron as the buffer tank, and you'll be satisfying calls for heat without ever firing the boiler. And then when the boiler does fire, because you got the nice wide differential, you'll have nice long run times. So those would be things, ways to improve that. A buffer tank would obviously do it as well, but this way you can maybe emulate a buffer tank.
Yeah, because you got
There was
a
a
good
question
large amount.
earlier.
Yeah. I guess we have to see how big the water content is of that boiler too, and how old that boiler is. How many years old is it?
Right.
So, but go ahead. Yes, John.
There was a question earlier, and could you use an indirect as a buffer tank? And I'm sorry we didn't get to it, and I hope the person who asked it is still with us. If not, then we can watch the recording. But there are buffer tank. There are indirects. Usually an indirect is a tank with your domestic and a coil with the boiler water. But you had one, Dave, that was the other way around, right?
Correct. Right. That's
Yeah. The tank was the boiler water and the coil was the hot water, domestic water. Now that you could use that as a buffer tank.
They actually have another model that is a buffer tank also. So it does have the 4 pipes, and
Yeah,
it's
okay.
actually got 6 taps on it. So the indirect tank that I have now is just a strictly indirect tank with the boiler
So it's
water
got-
in the jacket.
So it's only got 4 taps. So yeah, you need 2 gazinters and gazoutas just for the boiler water part of it, and then you've got your tappings for your domestic. So yeah, so you need 6 ports. Gotcha. That makes sense.
Right. So, but they do have another model buffer tank like that. So, and it even has the well, so you can drop it in that sensor too.
Mhm.
Why am I running a blank on the name right now? I know why. It's a long day.
Yeah, you've had a long day there, Dave. You should probably get back to your hotel.
What the heck is the name of it? I can't remember. It's in my own house.
Heat maker.
No.
Heat master.
Canadian. No, it's a Canadian indirect tank manufacturer.
I know I'm getting that way too, but I have an
Yeah.
excuse. I'm older than you. All right, I think it's time to flip all the cards here, young man. And
I think so
let's say
too.
thank you
Yep.
to the folks that are still left with us. We do appreciate your time. And Eric, thank you. And we're glad to be back on too. It's good to be back in the saddle again. And I'm looking forward to the next 5 weeks, and then hitting the spring season pretty hard. So thank you all. We will see you next Wednesday. Don't forget the Tuesday night as well. We're going to be back again on Tuesday night. So great to be back. Welcome back, Cotter.
Good to see
Vinny
you all.
and Epstein signing off. Take care, everybody.
See y'all.